Hello folks, this is Nitin welcoming you to the AI University channel where you can learn all your favorite digital technologies like machine learning, deep learning, AI, big data, Hadoop, virtual reality and cloud computing. In the previous video, we saw how to load our CSV data file as well as some data pre-processing steps. Okay. In this video, I'm going to develop the simple linear regression model as well as fit it as well so that it can predict the grades based on the time to study. So stay connected till the end of this video and this series to acquire the complete knowledge. Okay. If you're new here, then consider subscribing to this channel, or if you have already subscribed, then click on the bell icon to receive the notifications about the hottest technologies of 21st century. So let's move on to the coding part in order to build and fit our simple linear regression model. So let me open my Jupyter notebook real quick. So in this cell which is shown here, I'm importing a class, okay, called linear regression, okay, from scikit-learn's linear model package, okay. And in the next line, I am basically creating an object of linear regression class by calling linear regression, okay, followed by parentheses, okay, and I'm naming that object as linear regression, short form called linreg, okay. And in the next line, I'm fitting this linear regression object or linreg object on our training data set, okay. That's why I have mentioned the X train and Y train here. So I'm utilizing this method of linear regression class called fit here to fit this model on the training data set, okay. So first we take this object which is linreg followed by dot and then name of the method called fit, and inside the parenthesis we need to provide the data set on which we need to fit our model, okay. So in our case we want to fit it on the training data set called X train and Y train, okay, because the independent variable values are stored in X train and dependent variables are values are stored in Y train, okay. So we are providing these two parameters inside the parenthesis, okay. And when we execute this cell, we instructed our simple linear regression model to fit on training data so that it can predict the grades based on independent variable called time to study, okay. So folks, if you remember, our simple linear regression equation was y equals to a naught plus a1 into x, where a naught was intercept or constant and a1 was coefficient. So in the next line, I am printing the value of both a naught and a1 as you can see here, right. So a naught is intercept and a1 is coefficient. And I'm making use of simple linear regression object methods called intercept underscore here, okay, to find out the intercept value, and coefficient underscore method to generate the coefficient value. So you can very well see that a naught has value 1.3, okay, and a1 has value 0.27, okay. So our simple linear equation has now become grades equals to 1.3 plus 0.27 into time to study, okay. So now if we want to check what grades will I get if I study for 5 hours, so all I need to do now is to substitute 5 in place of time to study, okay. So 5 multiplied by 0.27 will become 1.35, and if I add this value to 1.3, then it will become 2.65. So what does this mean is, if a student studies for 5 hours, then he may get a grade of 2.65. Okay, please note that it doesn't mean that a student surely get this grade. There can always be deviations. Okay, he might get higher value than 2.65 or lower grade value than 6.5. So these models always provide estimated value. Okay, so this is the manual way of calculating the predicted values once we get the coefficient and intercept values. But we can also predict these grade values programmatically, and which is something I am going to cover very shortly. So in the next cell, I am predicting the grades using a simple linear regression method called predict, as you can see here, right? So I am using linreg object again here, which is a simple linear regression object, followed by dot, okay, and then name of the method called predict. Okay, and I'm utilizing the test dataset features, that is X test, to make these predictions. Okay, this will create a vector of predictions of test set grades called Y predict. Okay, so Y predict will contain this variable. Y predict will contain predicted grades of all the observations in the test data set. When I ran the cell, it generated the grade values predicted by simple linear regression model, which are mentioned here. Okay, so in the next cell, I printed the actual grade values. Okay, actual grades of using the Y test, because the Y test stored our if you remember, is storing 15 observations, and these are the actual grades of the students. Okay, so I am printing those actual grades here, which are shown here, right? So why am I printing these actual grade values? Okay, well, the intent is to compare both actual as well as the predicted grade values. So these are the predicted grade values and these are the actual grade values, and I wanted to compare these two. Okay, so let's pick Y test cell's first value, which is 2.1 here. Okay, and this is the actual grade of this particular student. Now if we see the model predicted the grade value for the same student, we could see that the grade value is 2.1157 and so on. This is very much close to the actual value of 2.1, right? Again, our model predicted a grade of 3.46 for the next student, and he had the actual grade value of 3.5, right? Which is so 3.46 is again close to 3.5. If I take third student's grade scores, okay, then you can see that the actual grade of that student was 2.4, but when we predicted it using our simple linear regression model, the predicted value came out as 2.38, which is again close to 2.4. okay, so you can see that all of these values make good predictions here. Okay, so folks, this is it for this video. To conclude, I explained how to build simple linear regression model using Python's scikit-learn package. I also showed how to plug in the coefficient values to the simple linear regression equation to predict the student grades manually. And then later on, we saw how to do predictions on the data, which our model has never seen programmatically. So we also saw the comparison of actual versus predicted values. So let me ask you a question from today's video. What is the independent variable in the following equation? Grade equals to 1.3 plus 0.27 into time to study. Please post your comments in the comment section given below so that I can get a chance to incorporate your feedback. You can also post your technical questions in the comment section and I will try to answer the same. If you are watching this video and you are not already a subscriber to our channel, consider clicking that little subscribe button And in case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me, guys. I will be covering next topic in the upcoming videos. So keep on watching. Thank you.